Hey guys, welcome back. So today's video is about this power supply over here. This is the final version of it. I started building it a few months ago. Well, what means starting? I built the first power supply a few months ago. We had on the left side this module over here with the upper switch for the left side and the lower switch for the right side. What we have here is a true two-channel power supply. What this means is we have two independent power supplies in one enclosure. And what this allows me to do is to connect them in series to create higher voltage, and also in parallel, which you can do even if they are from one internal power supply, as long as you don't exceed the power supply's limitation. So we have on the left side the main power supply. It's a buck converter. We have the voltage adjustment, current adjustment, standard potentiometers, no multi-turn potentiometers. If you build one of these as your main bench power supply, I highly recommend you go for multi-turn potentiometers like these. You see, with this one, it's in this position, it goes around, and that's the maximum this can go. And with this potentiometer, well, I can just go, and yeah, stopped. So it's a full, I think 10 turn potentiometer. Takes a lot of time. So definitely go for this one, as this allows you to adjust voltage much more precise. And this is also not necessary for current, not as necessary for current as it is for voltage. So buck converter on the left side, we have two positive and negative, these banana connectors. Now they do look like safety banana connectors, but they are not. I don't know, I just bought them. They can handle up to 20 amp of current. It's plenty for this. The power supply only delivers 5 amp here, 5 amp here. But these connectors, they don't stick out. That's a bit more how I like it. We have the upper switch for the left power supply, a lower switch for the right power supply, and on the right side, oh yeah, totally forgot, we have a 3-digit voltmeter, a 3-digit ammeter, same for the right power supply. We have a single knob, and that is only the voltage adjustment, as well as the two positive and negative banana connectors. The left power supply, buck converter, right power supply, buck boost converter, so I can even go for a higher voltage. And that is particularly nice if I want to connect them in series. The maximum I can get is what the internal two power supplies deliver, minus a small voltage drop. But as I do have a boost converter, I can get a bit further up. The two power supplies inside are 24 volt power supplies, but we will go to that in a moment. So this is how it looks from the front. You can see we have foam on the bottom, so that I can have it sit like this. And this is exactly on the height of my face in front of me, all the time sitting there. And this is the power supply that I use when voltage doesn't have to be 100% accurate, current doesn't have to be 100% accurate, or I want to just, let's say I want to power a small fan for a project. This is the one that I go to. It can also be set like this. I do have some foam on the back, and yes, a whole lot of nuts. So it can set in two positions. Something rattles inside. We will see what that is in a moment. So this is the power supply. And if you start out with electronics, I highly recommend you build one of these. With the only exception that you should go for a multi-turn potentiometer for voltage adjustment. It's just so much nicer, because typically you don't have to change voltage, like, I don't know, from 5 volt to 50 volt. A bit too much, but you get the point. You don't have to do it too many turns to get to your desired voltage. That's not how your typical workflow is. So I'm mainly operating this knob in this range over here, so yeah, very limited range of movement needed. With a multi-tone potentiometer, it's just way more precise, and you don't easily overshoot, which can be a problem for some projects. Alright, so from the outside, front side, this is the top. We do have two cable ties to hold some cable in place, you will see in a moment, and foam on the bottom, foam on the back, and we have this opening over here. Well, this is a vent opening. We have a DC fan directly behind this metal mesh, and 3 screws, as I made a mistake and the 4th one does not fit in here. And on the other side we do have the access opening as well as the IEC socket, so we vent all the air over here and have our power going in here. Now let's open this thing up and take a look inside, and then we can talk about how everything is arranged. Because you see, that is one thing I would not recommend you do if you start out with electronics. That is to use enclosures that are a bit small, because the smaller your enclosure is, the more compact the inside is, the more risk you have when it comes to mains voltage. There are things that you just have to consider, and if I open it up, you can see it's easily accessible. Everything is planned out to be serviceable as much as possible, but some things are just not. So let's start over here. These are the two before mentioned 24 volt 4 amp power supplies, so we have approximately 100 watt of power. The left side, just a quick thing, the left side DC to DC converter has a thermal shutdown and a maximum of 75 watt throughput, and the right one does not have that, but yeah, just also something to always keep in mind. You do have also limitations on what the DC to DC converter can put through. So let me just use this one more time. Yeah, that's a bit, let me swap it around. Alright, so we have the IEC socket, and as we use some metal meshes, it's always a good idea to ground them. So we have ground wire over here and also ground wire over here. So these metal meshes are always safe to touch. If you start out with electronics, it's always good to use plastic enclosure. If you don't use a plastic enclosure, you definitely have to ground your enclosure to make sure that it's safe. So 2 power supplies over here, and you may already see that I have some Kaplan tape all over these edges, as well as a piece of clear tube over here. Now this is done over here, this is done because I have this central cable tree. This is the one that goes to the 2 mains switches. As you can see over here, all the main switches connections have heat shrink on them. That is really important, as we have mains voltage over here and secondary side direct output voltages over here. So you have to make sure that the best thing is that cables are far away from each other. And if you take a look inside, these are the only secondary side cable that directly cross mains cables, and we do have over a centimeter of space, so they never actually get in touch. Therefore they don't run the risk of rubbing against each other and eventually shorting. So yeah, if you are so close, you need on all of these connections, you need heat shrink to make sure that everything is safe. Then we have our mains voltage coming in, and as you can see, both are obviously isolated, insulated, whatever. I have heat shrink on them on live and neutral. I bend them backwards slightly, and they go underneath the first power supply over here. And here's something that I do quite often. If mains cable run underneath the power supply or close to edges or something they should stay away from, I use clear tubing around the mains cable with some zip ties along the way to make sure. And there's what was inside, just a piece of zip tie. Oh, another piece of zip tie, and another one. Oh, very interesting. Okay, yeah, so this protects the cable. This is no additional insulation. This is just a physical barrier and a cutting protection so that the cable are further away from whatever they should stay away as this possible, as this power supply, the underneath, as well as the sharp edges from the component legs, so it prevents the cable from getting cut. That is definitely something I do recommend, that you have just some clear tubing. Then we do join these 16 AWG wires over here into 18 AWG. It's not necessary to use 16 AWG in this case, as yeah, the power supply in total only uses 200 watt of power, 100 here, 100 here maximum. This is just something that I did the first time I built it. I was just too lazy to use other cables, but afterwards it was better to use these 18 AWG cables, as they are also more flexible. And as you can see, it's orientated that this cable tree and this these middle column on the top side sit right in between the two power supplies in this middle over here. And again, we have some protection for all these sharp edges. There is no sharp edge that could potentially cut into the cable. But yes, we do cross secondary sides, so if necessary, if you're too close, I did a lot of testing and a lot of reviewing of this design, you should definitely maybe insulate these cables a bit more. But generally, if you're a beginner, stay away from enclosures that are too small. Then we have the power supplies, they do their magic. And we have secondary side, a 24 volt, maximum 4 amp coming out. We have one pair of cables, 16 AWG, coming from the right power supply over here, and two 16 AWG positive negative from the left side. These go over here, and then let's turn this around slightly. You may be able to see it. So so these two over here go into the buck boost converter, and the other two cables go underneath these cables, the buck boost converter underneath the mains cable, underneath the buck converter, over to the two solder joints of the buck converter. And this is done because of spacing. You see, I modified this fan over here. And that was because initially I used these two screw terminals, and with the original configuration I had to remove this and it worked. However, when I changed, like for example, I now have a temperature controlled fan. I'm using one of my famous temperature controlled fan circuits using the LM317, and I'll put a link over here. I had to just completely change it. We will get to that in a moment. So yeah, these are the two pairs of cable for the left and right power supply, going to the left and right power conversion modules. Then we have obviously the appropriate cabling, power for the volt and ammeter, the yellow one for measuring the voltage, these thick ones for measuring the current, the buck boost converter. As you can see, I right now have a single heatsink on top of the main IC. However, I'm going to apply another heatsink on both of these inductors to get the heat a bit faster away, and also to cool them down so that there won't be a problem in the future. And underneath we have the potentiometer, and this module has two screw holes and I have some standoffs, so yeah, that's totally fine, no problem here. The two banana plugs are glued in place. Use just 2 dabs of glue on each so that this nut doesn't slip. With the original one I have hot glue. Works, but yeah, rather use proper glue. Now this side is a bit more cramped and also a bit more to talk about. So where do I start? So we have again the same cabling essentially, except for now what I did here. I have 3-pin connectors. Oh, that's so hard to see. We have 3-pin connectors. You see from one of these very long multiple pin strips, male and female, cut down to 3-pin, inserted into the holes for the current and voltage adjustment potentiometers that were originally installed. Now these can be plugged in and plugged out, and the cable will go underneath to the potentiometers, which you can't see. The module itself is glued down onto the 2 potentiometers, and we have also this over here, this contraption over here. Now this, yeah, that was something. You see, I have multiple holes in the front that are not used. I had to change this design multiple times, but now I have a piece of copper screwed in place with a single standoff over here, and this copper goes up and underneath this heatsink, right on top the main IC. We have thermal paste between the DC to DC converter module and the the copper, and I stuck just a heatsink on top to, well, actually cool it. The copper is actually just in place for this probe over here. This is an NTC thermistor that is used for my temperature controlled fan circuit, and we run these cables over here, under here, and this is the temperature controlled fan circuit. Here's the LM317 with its own heatsink, and we have fixed values. The fan reaches 100% speed at 65 degrees Celsius main IC temperature. And because we have 2 24-volt power supplies inside, I decided to have a DC to DC converter, a smaller DC to DC converter between the temperature controlled fan and the 24-volt circuit. And this is made for 2 reasons. Number one, the fan is a 14-volt fan, so if it ever goes above that, it would just break. And the second thing is that the LM317 gets quite hot if we have to drop from 24 volt to typically 6 volt. 6 volt is the typical value it runs at. It's so efficient, it rarely ramps beyond like 7-8 volt. Although we are measuring temperature at the hottest point, and I use this power supply mainly, and that is also the reason we have the probe over here. And yeah, so that is how it looks. And we have obviously the fan cables going over here to the fan, and yeah, so this is the finalized version. Have 2 power supplies inside, the fan is temperature controlled, they are independent. We have floating ground, we can't connect them in series, obviously we can connect them in parallel. Each power supply, maximum 100 watt. This module over here, maximum throughput 75 watt, it does self-regulate. This module, I don't know if it self-regulates, I don't think so. So we are well underneath the power supply rating, and this also won't be used for anything too crazy. And yeah, so this is my finalized version, and I highly recommend that everyone has at least 2 power supplies, or rather 2 channels, because okay, so in my case I have 3 power supplies. My main bench power supply that is very precise, and this one over here, and I can tell you so many projects I use all of them. But also I have to say that as of right now I don't need a 4th one. 3 is for me totally fine. Most of the time I use a maximum of 2, and yeah, so 2 is totally fine, 3 is preferable. And this project is also not very expensive. The original power supply was $30. If I consider the additional power supply, cabling, additional module, all the additional stuff, as well as the fan controller, I'd say this project, as it is right now, would cost approximately $70, and that is a well, no, $60, because the enclosure we don't have to buy it one more time. So yeah, 60 approximately 60. Yeah, okay, I think we get close to $55 to $60 for this power supply as it is, the finalized version. And so yeah, I hope you like this video and small review of my final bench power supply, this awesome 2-channel one over here. It sounds expensive, but viewed like this, if you start with one power supply, use a bigger enclosure if you're new. If you're not new to electronics, you can use same sized or similar sized enclosure, and just start with it and build from there. I also started with one power supply and added the second one over time, as well as in between I added the temperature controlled fan. And ever since, it works totally fine. As it is right now, I have this thing in use for 2 months. And yes, I'm using 3 power supplies. So I hope you liked this video, and if you did, please leave a like, comment down below. And other than that, thanks for watching and see you next time. Bye!